as per Bronsted, the acids are the species who has a tendency to lose a proton. So that means if this is a species, it has tendency to lose a proton. Okay, so this is as per Bronsted known as acid, right? So then base is nothing but a species who has a tendency to accept proton. So if this is base BH, it is tendency to have to accept a proton. So it creates BH2 plus over here, and this is base as per Bronsted. Okay, so now I have already discussed what are Lewis acid and Lewis base in our earlier videos, especially basics in organic chemistry. So if this is the case, so if this is acid, then what is this is known as A minus, which is known as conjugate base. Conjugate base. Okay, and since this acid is giving H plus to medium, so medium pH also play very important role in their dissociation. This is dissociation, and this is association. Okay, normally dissociation we denote as Ka. Okay, now the association previously is denoted as Kb, but now we are also expressing the strength of basicity in terms of Ka. How? We are going to see. So now, if you see, the acid produce a conjugate base, where base produce a conjugate acid. Conjugate acid. So now over here, if I wanted to know that how this dissociation process takes place, so I can write the as per the kinetics. Okay, the dissociation rate constant is nothing but A minus into H plus upon AH. Okay, this can be written, and this can be also written in this fashion, like if I separate H plus into A minus upon AH. Okay, the top one is the ionized form and the down one is unionized form. Okay, so if you take log of both the phase, log K, then it is A into B, log A into B, log A plus log B. So log A, it is log H plus log, it is as it is A minus upon AH. Okay, now if I insert minus sign everywhere, the negative sign, okay, so then it become like this: minus log K is equal to minus log H minus log A minus AH. Okay, I have introduced minus sign. So minus log A is known as pKa, what I have mentioned over here. Minus log H, it is pH, minus log A minus AH. Okay, and this is famous, your Henderson Hasselbalch. I hope I should not write wrong spelling. Hasselbalch. Okay, E. Hasselbalch. Okay, equation. This is very famous, and this is for acid. So in Growwell, we modify this equation into, if it is acid, then we can write pH minus pKa. Okay, this I have changed the sign, is equal to log, if it is acid, A minus, so ionized upon unionized. So this is for acid. Okay, now for the base, it can be written the reverse form: pK minus pH is equal to ln ionized upon ionized form. So this is a very important expression, the relationship between pK and pH. Okay, so now we must understand the acid and basic scale. Okay, acid and basic scale. So if 0 to 7, 7 to 14. Okay, normally this is acid and this range is base, right? But there are weak acids and weak base. So the weak acid fall over here and weak base fall over here. Remember, if weak acid pK is going down, okay, going towards this side, it may shift to weak base. It cannot become strong acid. Okay, weak remain weak whether they are acid or base, but weak base, if their pK is going up, it become a weak acid. It cannot become a strong base. Okay, so this is a weak become weak, but acid. Okay, if the acid pK a pH, so if it is a pK, you can say this is pK scale as well. Okay, so acid pK, if it is going down, then it is the strong, the acidity increases. Okay, it becomes strong acid. And the base scale, if it is going up, it becomes strong base. Okay, so now I give some example of acid and base. And now you have perchloric acid, which is the strong acid, perchloric acid, HClO4, even sulfuric acid, hydrochloric acid. But the moment you have acetic acid, okay, then you have phenol. They are the weak acids we consider. Okay, even your formic acid. Now if it is base, strong base, we normally go for hydroxide, that is sodium hydroxide, potassium hydroxide. These are known as strong base. But when you are talking about like, remember, anything is ionized form, they are strong base. Okay, like if I say sodium methoxide also, they are not as weak base as, like example I give, weak base ethanol is very weak base. No, not sorry, ethanol. Weak base, we can ammonia. Yes, ammonia is a weak base. Then methylamine is a weak base. Okay, these are the weak base. Okay, now in that case, these are the example. So if you see, the pK value is very important to understand the acidity and basicity. So let us discuss the strength of acid and the base. Okay, now over here, from this equation, from this reaction kinetics, we can understand if conjugate base is more stable, okay, the acidity increases. If conjugated base is more stable. How? When the conjugated base get more stable? Simple. When it is associated with electron withdrawing group or